Well, hello there. This is lesson 48 in Saxon's Algebra 1, the third edition. And this lesson is on polynomials. This is a fun lesson, so let's just go ahead and get started. All right, polynomial. Poly is a prefix that means many. Nomial comes from the Latin nomen, which means name. So, in mathematical terminology, if we have one single term, we call that a monomial. Mono means single, okay? If we have two terms added by a plus or a minus sign, then we have a binomial, which bi, means two. The same thing here. Three terms would be called a trinomial. If you have more than three terms, four terms or more, you're going to use the term polynomial because there are just many terms. All right, let's talk about what is not a polynomial. This is not an example of a polynomial, even though it's three different terms added by with addition or subtraction signs in the middle. You cannot ever have a variable in the denominator in a polynomial. The same thing in this one, t to the negative third would be the same as 2 over t, which would make it a variable in the denominator. You cannot have a radical term. And here in this one, again, there is a variable in that denominator. Okay, now polynomials can have what is called degrees. And the way you determine the degree is, look at these different terms here. There are the different terms. Now technically, like I told you, this should be a trinomial, but really polynomial can be any named term. This one has a degree of 2 because this is the highest exponent. In this one, it is an 8th degree polynomial because it has an exponent of 8. This one is a 3rd degree. This one, a 1 degree. Okay? This one, a 5th degree. And this is a 0 degree because 6 to the 1 is 6. So it's just 1 really. It doesn't, if there's not a variable, there is no degree. Alright, so this hopefully helps you see it a little bit better. This makes it a 3rd degree term because we've got 3, 2, and 1, or actually none here. Alright, polynomials can be added together by combining like terms, and that's why we've been learning to combine like terms and see what like terms look like, building towards this concept. Alright, so if I take all of these out of the parentheses and I just line them all up, I'm going to see that I've got some that are like terms. So let's see what I could add and get this out of here. 2x squared and 3x squared would give me 5x squared. And then 3x plus 5x gives me 8x. And then 5 plus 7 gives me 12. So that's how you do it. It's very, very simple. Adding them vertically, I actually like to add them vertically better. So we've got 4 choices for answers here, A, B, C, and D. We're going to see which one is correct. We're going to add 3x cubed minus 5x squared plus x. And then we're going to add 4x cubed plus 2x squared minus 4x. We're going to use the vertical format. That just means that you line up like terms under each other, okay? And you keep the sign with them. So when I add 3x cubed and 4x cubed, I'm going to get 7x cubed. And negative 5 and positive 2 is negative 3x squared. And negative 4 and positive 1 is negative 3x. So you can see it would be choice C. Alright, now here we have the original standard form problem, and we're going to write it in vertical form, adding like terms, keeping like terms together. So I've put this x squared under this 6x squared. I don't have any x terms in this one, so I just leave that blank, or I could put 0x there. Right here, I could put 0x. Same thing as a placeholder. Alright, and then -4 and -7. So when I add those together, 6 plus 1 is 7x squared, 3 plus 0 is 3x, and -4 and -7 is -11. Alright, here's another one. Here is standard form written out horizontally, and then we arrange them in the columns of like terms. If there is an absent one, like here, you can put a 0 as a placeholder if that would help you, and then you just add. Okay, so let's do our practice problems. Here we've got negative on the outside of this parenthesis, so we know that that is going to distribute over every term, and it changes every term. So let's write it out correctly. Negative 3x to the 5th, negative 6x to the 4th, positive 7x cubed. There are no x squareds and no x's, so I'm going to put placeholders in there with 0 and 0, and then positive 5. Alright, and then here, this is a plus sign, so all of these terms would stay the same, and I'm going to add them up vertically where they belong, and then I'm just going to add. So I've got -3 and positive 1 is -2x to the 5th. -6 and -1 is -7x to the 4th. Plus 7x cubed plus 3x squared minus 2x, and -8 and positive 5 is -3. And that's our final answer. Okay, same thing here. This negative sign is going to distribute over each one of these terms and change the sign. So let's write them correctly and write them in descending order of the variable. That's why you've been learning to do this. So if you've got x to the 4th, that's the highest degree. You're going to have something in every place all the way through. Okay, so we've got and this x to the 4th came here, and see, you can see that this, in this top term here, these things are out of order, so we're going to order them greatest to least. Alright, and then I'm going to apply this negative sign over each one of these and write them in the appropriate place with their correct sign. When I've done all of that, I'm going to have -15 and positive 1, put a 1 there, is -14x to the 4th minus 2x cubed plus 9x squared minus 11x plus 5. And that is all there is to it. I think it's a fun thing to do. You just have to make sure, especially if you've got one of these on the outside of your parentheses, that you change every term inside the parentheses and line them all up under each other, leaving placeholders when you need to. And that's all there is to it. I'll see you tomorrow for lesson 49.